All right, so this is a lesson Tyler and I did last semester in EMAS 300. We were looking at Pythagorean theorem to solve problems, and that's really bold. Basically what we did, we turned this kind of into a project inquiry-based type lesson. So what we did was we presented each student with a pet that was going to be theirs to take care of because they did so well in their last unit. That was their background information behind it, so hopefully your students will do well before. So it was going to be a weird pet, a giraffe, an elephant, a fish, something abstract that they wouldn't normally have at home, like a cat or a dog. After that, we were going to also reward them from doing so well that NASA had called them, and they were going to be going to the moon to work on a special project. On the moon, they had to take care of, you can go down to stage 3 there. On the moon, they had to take care of their pet because their mom didn't want to take care of it. And in doing so, they had to, let me find this one. They had to construct a separate building that the pet would live in because there wouldn't be enough room in their living quarters. So it would obviously change from pet to pet, person to person. The first thing they'd have to do in their group is to sketch, just with pencil, a little design of what they were going to do. Then they were going to make a 3D model using Google SketchUp to make a 3D thing of it so they can actually see if it's going to work. And then the last step would be to make a scale model out of anything. They could use Lego, they could use toothpicks, they could use Play-Doh. It doesn't really matter as long as it was scale modeled. And they had to meet certain criteria. So they had to have at least 2 square corners and 2 non-square corners. Now they didn't know what a square corner was at the time. They had to establish their own definition. They had to include at least 2 different 3, 4, 5 Pythagorean triples and at least 1, 1, root 2, 1, 1, 1, root 2 right triangle. They had to have 2 non-right triangles. They had to make sure that their pet could live comfortably and the structure couldn't be too big or useless or have useless features because NASA wouldn't pay for that. At the end, they would have to justify each part of their design to their classmates in a quick little presentation, making sure that they've met their criteria and to share with their peers to see if they can get any other ideas. The other thing they had to do this entire time was a journal, and they would have a chance to name it their space journal or their math journal, whatever they wanted to call it. And in that journal, they had to record all the steps that they took in their design process, so how the drawing went, how the SketchUpping went, how the scale modeling went. They had to understand that they had to record any questions that they found or encountered while creating their design and how they attempted to solve them, and the answer that they found. They had to keep track of any calculations they used, so those would come in really well when they're doing the scale models, doing proportions, getting the angles right to use in SketchUp. And as the very final entry of their journal after their presentation, they had to talk about the most critical part of their design, how proportional reasoning helped or didn't help them with their design, what question they asked and learned about in their journal, and what makes this corner square. So what was their definition? And that's our summary. So who's next?
Okay. So for the set, they just did a Pythagoras theorem review, and they explained a squared plus b squared equals c squared, and how it doesn't always work depending on how your triangle is labeled. But instead, we wanted to modify the lesson. So we asked the students how their yesterday afternoon was, or something about their day, just to welcome them and say, hello, welcome to my classroom. I am on your side. I'm not big and scary. And then they had to do an entrance slip to get students to submit what they think Pythagoras theorem is. So instead of saying, this is Pythagoras theorem, let's talk about it, saying, what do you remember? When did you learn about this? What are your thoughts and feelings about it? And then we would go over that slip as a class, still including the real meaning of a squared plus b squared equals c squared. And then we'll use our retrieval strategy, so our H with a circle. And then we'll do a KWL journal entry. So we'll open up their beautiful journals that they're going to start, and we'll ask them what they want to know, what they know, what they want to know, and how they're going to learn it. So they'll do a KWL journal entry for that.
Okay, and with development, you kind of heard that they were assigned an animal to build a structure for and keep a journal of their progress. We wanted to get a little bit ethno-mathematical with it. So depending on their ethnicity, their country of origin, whatever the case may be, they were going to pick an animal that's native to that area, explain the size, specific needs, make sure they actually understand what this animal needs before they start designing for it. And the teacher could provide a list of animals if they're stumped and their origins for their students. And we could go a lot of different directions with that depending on the diversity of your classroom.
Alrighty, so for the closure, just Cal's initial one was just doing the final journal entry, but we decided to take it a step further and introduce the next assignment, creating that connection. So the next assignment would be like unit pricing of materials and how they can use it and proportional reasoning and that kind of thing. And then they would finish their KWL journal entry for what they learned, and Nicole's going to talk more about that in assessment.
Okay, so in the original, the assessment was mainly just the journal and the final project, but we wanted to include different kinds of assessments. So we included a self-assessment on how they think they did on the project, a peer assessment that the peers will fill out while the students are presenting, and the KWL journal entry. So here's the KWL journal entry, where they fill out what they want, what they already know, and what they want to know, and then after they fill out what they learned. And then here's the self-assessment, which they'd answer these 3 questions after they were done the assignment. And then the peer assessment, the peers would answer these 3 questions while the students were presenting.
Okay, so for adaptive dimension, mostly Kyle just had content procedure adaptive dimensions. So we wanted to look at modifying the content procedure as well as different types of learners. So we wanted to appeal to the auditory learner instead of it being solely inquiry-based or solely whatever. So that's kind of where the Passaic graph actually came from. Originally with our lesson study. So we could use tools like the Passaic graph or call up any other YouTube videos we know, or have the students rap about it, or have them find a different resource or look for a different resource ourselves so that the students get a variety of different instructional techniques instead of just one, you know, here's a book and here's a project, because some students don't work that way. Or they could work in groups or they can work independently, whatever is going to suit the student and their learning style best.